Hi guys, this is what we have in this example. So essentially this is a problem that invokes a normal distribution, and we're going to do some variations on it. So let's begin. So we are told that the total amount of coffee dispensed into a coffee cup by a coffee machine follows a normal distribution. So the first thing that you need to do is x follows a normal distribution with a mean equals to 150 and a standard deviation of 10. So this is what you do. Remember, this is 10 squared because from a default format, what you do here is a variance, not a standard deviation. So remember that. And we are also told that the coffee is sold at the price of 1 per cup. So for now, let's leave it at that. However, the coffee cups are marked at 137 milliliters level, and any cup of coffee below this level will be given away free of charge, okay? So this amount of coffee dispensed in different cups are independent from each other. So what this means is that the result from one guy doesn't influence the result from another guy. So the first question is to find the probability that the total amount of coffee in 5 cups exceeds 700 millimeters. This is one thing that you need to know about these problems, is that sometimes they will give you a multiplier. Let's look at this exact example. 2 cups, this one is 1 cup. So all we are doing here, every time that you have a situation like that, and for this first problem, what we have here, essentially, before we start in doing some math, we are doing this as like this. So n, so follows a normal distribution, but we have 5 cups. So it's 5 times 150, that's 750. And 5 times 100 is 500. This is the first thing to do, because if you don't do this, you're gonna get a false result. So essentially, when you're doing this problem, so now we are saying that the probability of total amount exceeds. So essentially, it's the probability of x exceeding 700. This is all that you need to calculate. So, but we needed to make this first step in order to make the correct numbers inside. So in order to calculate this, we need to normalize the distribution in order to get it in this format, 0, 1. So we're going to normalize the distribution. So in order to do that, we're going to say that the probability of z is greater than 700 minus 750, which is, this is the elements that we have in order to normalize it, divided by the square root of 500. This is all we are doing here. And this is equal to is greater than minus 50 divided by the square root of 500, which is equal to, so this is a negative number. This is the probability of z is greater than minus 2.23. So before we dive into any more calculations, we need to know a couple of things from here. So when you have a situation like this, let me get the values inside here. So when you have a situation like it's a probability of x is greater than minus x, so every time that you have here, you change the sign. This is the trick that you can do in order to not get any mistakes in these exercises. So if you have this situation that is a negative, you change this guy. So it's less than x. And because a CDF function is about having a situation like this, it's the area under the curve, where the probability of x is less than x. So essentially, you go to the distribution table you can use any statistical table that you have, and you're going to find the entry for 2.23, and you'll find, because it's positive, and you'll find that that value is 0.9871, which is the answer for this problem. For the second one, pay attention to this one, because this is kind of a trick question. You are asked to find the probability that the difference in amounts of coffee in 2 cups, remember the multiplier, is smaller than 20 millimeters. So essentially what they are saying here is that x is between minus 20 and 20. Notice that you're not standardizing here anything. You are already being told that the difference is between minus 20 and 20. Okay, so you are asked this, what to calculate the probability that the difference is between minus 20 and 20. So when you do the calculations and you are standardizing, remember that this is 2 cups. So we have this expression, normalize it's between 150 and 100, and because we have 2 cups, now this is 300 and this is 200. But you're not doing anything in the numerator because they're already telling you that the difference is this one. This is the main thing, because otherwise you'll be doing some weird calculations and end up with numbers that are off bounds of the statistical table. So what you do here is the probability, we have Z now, so it's minus 20 divided by 200, because it's 2 cups times 100, so 200. Z, and then the positive version. So this will give you, by checking the table, this will give you a value. This is the same thing as having this. So this is the entry that you find in the table, minus 1 minus this. You need to memorize this expression every time that you have a situation like this. This always leads to this result. So this is the same thing as having 0.92 minus 1 minus 0.92. And this will give you the value of 0.84. For the next one, you are asked to find what is the probability that 1 cup, remember your multiplier, is filled below the level of 137. So this means that you're looking for the probability of C is below 137. This is what they're asking you to do. So in order to solve this problem, this is the same thing. So we have X follows a normal distribution of, the first one is 150, and then we have 100. So in this specific case, we have 137, and we are going to normalize in order to get the Z value. So we have the probability of 137 minus 150, because this is only 1 cup, we have 100, and this is the value that you're looking for. So what's the probability of Z being less than this number? And you'll find that this is the probability of Z being less than minus 13, because it's 137, 150, that's minus 113. So 13 divided by 10. So if you check out the entry for this value in the table, remember when we have the negative number, again, this is the same thing. When you have, every time that you have a negative number, I always do it like this in order to not get the wrong number. So minus X, it's the same thing as having the probability of Z greater than X. And because the whole point of this table is to finding a value that is less or equal than a value, and you have this version, you do this 1 minus X, the value that you have inside. And if you check the table, you will find that this value is 0.0968. For the last one, you are asked to find the expected income from selling 1 cup of coffee. And we know from the initial statement that the coffee cups are marked at 137 milliliter level, and in any cup below this level will be given away for free. So the expected income, let's name it as I, is 1 cup times the probability of you selling a cup. So this means that it must be greater than 137. And we found that from the previous one, that the probability of C being less than 137 was 0.0968. So since this is the reverse, so all we are doing here is 1 minus 0.0968, which gives us a total of 0.9032. So here, since it's only 1 cup, so this will give us the value of 0.9032.